Hello and welcome to section 8.3. Today we're going to look at multiplication properties of exponents. When we go to multiply a power and that power has the same base, then we can go ahead and simplify this power and use the same base but one exponent. So if we take a quick look at an example here, the example of 2 to the 4th times 2 to the 6th, if you break this down, 2 to the 4th is really 2 times 2 times 2 times 2. Then we're going to multiply that by 2 to the 6th, which is 2 times 2 times 2 times 2 times 2 times 2. So if you notice, all of these bases are the same, and if we count them all up, I have 4 and another 6. This is actually going to give me 2 to the 10th power. I got that 10 by adding up the 4s. I have 4 2s, and then over here I have 6 2s, so 4 plus 6 equals 10. So if you have the same base and it's being raised to a power, then what you can do to simplify that is you keep the base the same and you add your exponents when you are multiplying. So we can rewrite this and say 2 to the 4th times 2 to the 6th becomes 2 to the 10th. So again, just to reiterate, since the bases are the same and we're multiplying, we can just go ahead and add the exponents, and that's how we get 2 to the 10th. So this is going to lead us into the property that says multiplying powers with the same base. So for every non-zero number a and integers m and n, a to the power of m times a to the power of n is going to equal a to the m plus n. So again, we can look at some examples here. 3 to the 5th times 3 to the 4th. I keep my base of 3 the same. I add 5 plus 4 and I get 3 to the 9th. Now let's go ahead and look at a few examples and work them out ourselves. So for example 1, part A, we're going to rewrite our expression using each base only once. So again, for part A, I have 5 to the 3rd times 5 to the 6th. So my base is going to be 5, and I'm going to add my exponents, which is 3 plus 6. So I end up with 5 to the 9th power. Likewise, for part B, I have a same base of 2. It's being multiplied. So this tells me my base is going to be 2, and then I have 4 plus a negative 3, which is really 4 minus 3. So this is going to give me 2 to the 1st power. For part C, now here I have more than just 2 that are being multiplied, but it's the same principle that's going to apply. I see that I'm multiplying 7 to the negative 3rd times 7 to the 2nd times 7 to the 6th. So my base is going to stay the same, and I have negative 3 plus 2 plus 6, or I end up with 7 to the 5th power. And this is my final answer. For example 2, it's similar to what we did in example 1. However, we're going to put a little bit more complexity to it. Notice in part A, we have n to the 2nd times n to the 3rd times n to the 1st. Okay, if there's no exponent, remember that it's really a 1. Now here, we're going to multiply any whole numbers that we have first. So I have 1n squared times 1n cubed times 7n. So this is just going to be 1 times 1 times 7, or 7. Now I'm going to look at, I have the bases of n, and I'm going to add their exponents. So I have 2 plus 3 plus 1. So this is going to leave me with 7n to the 6th power. For part B, here I have a 2, a 7, and a 2. So 2 times 7 is 14 times another 2 is going to give me 28. Then I have just an x squared. So I'm going to leave x squared there. And then for my y's, I see that I have y cubed times y to the 4th. So this here means I have y, that's my base, and then I have to the 3rd, and I'm going to add my exponents, so it becomes y to the 3 plus 4, or I end up with 28x squared y to the 7th, and that is my final answer. For part C, I have m squared times n to the negative second times 7m. So again, I'm going to start out with my whole numbers, and here I have 7. Then I have m squared times m to the first. You may want to write a 1 if you have just a variable, just to remind yourself that there really is something there. So this is really 7m to the 2 plus 1, and then I have to multiply by that n to the negative second. So now when I simplify, I have 7m to the third n to the negative second. I do have to keep in mind my properties of exponents. And I say that because when I have a negative exponent, remember that's telling me that it's in the wrong spot. So in this case, that's really in the numerator, which tells me then that that n to the negative second really needs to go to the denominator. So my 7m cubed is going to remain in the numerator, and my n squared is going to go to the denominator, just like this here. For the next one, I have 2n to the fifth times 3n to the negative second. So 2 times 3 is 6. N to the fifth times n to the negative second really becomes n to the third. And notice if I go ahead and multiply my bases first, in this case my negative exponent kind of took care of itself, and I'm just left with 6n to the third. Finally, for the last part, I have 5 times 2 times 3 is going to give me 30. I have x to the first times x to the 8th, which is x to the 9th, y to the 4th, and I can go ahead and leave it just like that. And I do apologize on example 3 here. Not everything came through like it was supposed to, so I just went through and I rewrote all the problems in yellow. So for example 3, I have 3 times 5 is going to give me 15. I'm multiplying d to the negative fourth times d. So this gives me d to the negative 4 plus 8. So negative 4 plus 8 is 4, so that leaves me with 15d to the fourth. Likewise, for the next one, I have a to the third times, remember, I'm just going to write a 1 in there so I don't forget about it. So this becomes a to the 3 plus 1, or a to the fourth. For the next one, I have negative 8 times 4, which will give me negative 32. M to the fourth times m to the 8th will give me m to the 12th. Next, I have 3 to the 8th times 3 to the 5th. Well, this is 3 to the 8 plus 5, which is really 3 to the 13th. For the next one down, I have p to the 7th times q to the 5th times p to the 6th. Well, with this one, I'm going to simplify my p first. So p to the 7th times p to the 6th is really p to the 13th. And then I'm going to multiply that by q to the 5th. And then for the final one here, let's slide everything up just a bit. Okay, and for this final one, I have r to the 7th times s to the 4th times s times r to the 3rd. Whenever I see just a single variable, I'm going to go and put the exponent of 1 in there, and I'm going to collect my like terms. So I end up with r to the 7th times r to the 3rd. That becomes r to the 10th. S to the 4th times s to the 1st is really s to the 5th. And for our last example, I have 2 to the 8th times 2 to the negative 9th times 2 to the 3rd. This is going to give me 2 to the 8th plus negative 9 plus 3, or 2 to the 8 plus a negative 9 is going to be a negative 1. Negative 1 plus 3 is going to give me a positive 2. So 2 squared is really 4. For this next one, I have 1 divided by, now I have b to the negative 7th plus 5. So this really gives me 1 divided by b to the negative 2nd. And again, I have that negative exponent in the denominator. The negative tells me that it's in the wrong spot. So this is really going to end up being b squared. For the next one, I have 1 divided by t to the negative 5th times t to the negative 3rd. So this is really negative 5 plus a negative 3, or I end up with 1 over t to the negative 8. T to the negative 8 is in the wrong spot, so I need to move that up top, and I get t to the positive 8. And then for my last one, remember, anytime I have a power raised, power raised to the power of 0, or with an exponent of 0, this is always going to be 1. So this really means that I have f to the 5th times f squared is going to really become f to the 5 plus 2, or f to the 7th. This is the last example. Please let me know if you have any questions. Otherwise, I hope you guys have a great day, and we will see you in class.